You ever notice how a shop behaves right before it dies on you? It's not a sudden cardiac arrest. It's more like a slow, wheezing protest. You're mid-rip on a piece of walnut that cost more than your first car, and suddenly the saw blade starts sounding like it's chewing through wet taffy. The lights dim, just a hair, the dust collector moans, and then, pop, total darkness.
I've seen that look on your face, Tiger. It's the look of a man who just realized he has to finish a cut by candlelight.
It's worse than that. It's the sound of the refrigerator in the kitchen stopping too, which means my wife is about to come out here and ask why the Wi-Fi is down. I spent years graduating from one extension cord to a three-way splitter, thinking I was a genius for running a 15-amp table saw and an 11-amp vacuum on a circuit meant for a single light bulb and a garage door opener.
Which is exactly what most of us are doing. We treat the garage outlets like they're infinite magic portals. But today, we're actually going to talk about doing it right. No more pop goes the breaker. We're diving into electrical planning.
And look, I'm a woodworker, not a lightning bolt wrangler. You should always have a licensed Sparky do the final hookups and check your math. But if you don't plan the layout, you're letting someone who doesn't know a joiner from a jukebox decide where your power goes.
Okay, so where does the average person even start? Because opening a circuit breaker box feels a bit like looking into the stomach of a robot.
You start with a power audit. Take a notepad, not a mental one, a real one, and walk around your shop. Look at the silver nameplates on every motor. Don't guess. My old compressor said it was 5 horsepower on the sticker, but the motor plate told the real story. It was pulling 15 amps just to stay awake.
So you're just making a grocery list of electricity?
Exactly. You need the simultaneous load. You aren't running the lathe, the bandsaw, and the drill press at the same time. But you are running the table saw, the dust collector, the overhead lights, and maybe a space heater if your shop is as drafty as mine. Add those up. If your total is 18 amps and you're on a 15 amp breaker, you're basically asking for a fire or a ruined motor.
Is that why tools sometimes feel weak, like they're struggling?
That's the voltage drop monster. When your circuit is maxed out, the voltage dips. The motor tries to make up for it by sucking in more current, which turns into heat. You aren't just tripping breakers, you're slowly baking the expensive copper windings inside your tools until they smell like a burnt toaster.
You mentioned earlier that the biggest mistake is running everything back to the main house panel. You're a big fan of the sub-panel approach, right?
It's the only way to stay sane. If you run one big, beefy feeder cable from the house to a dedicated box in the shop, you've basically built yourself a local power station. If a breaker trips, and if you're pushed for time, it will, you aren't hiking across the house in your sawdusty boots to the basement. You just reach over and flip it.
What's the Goldilocks size for a sub-panel? I see 60 amp, 100 amp.
If you can swing it, go for a 100 amp service. The price difference in the box itself is peanuts. It's the future-proofing tax. Today you're making birdhouses. 2 years from now, you might buy a welder or a big CNC machine that eats electricity like a hungry teenager.
Let's talk about the big boy outlets, the 240 volts. For someone starting out, that sounds intimidating, like industrial level stuff.
It's actually more efficient. Think of it like a garden hose. 120 volts is a narrow hose trying to push a lot of water. 240 is a fire hose. Most big cabinet saws and 5 horsepower compressors actually prefer it. They run cooler and start up faster. I remember when I finally switched my main saw over to 240. It went from a hesitant via room to just instantly being ready to work. It feels like the tool finally has enough air to breathe.
But wait, if I'm planning my layout, how do I know where to put these? My shop layout changes every 6 months because I'm obsessed with workflow.
Ah, the shop shuffle. I've moved my workbench so many times it should have its own GPS. That's why you don't just put one outlet every 6 feet like the building code says for a living room. In a shop, you want overkill. I like to put outlets at waist height, about 42 inches, so I'm not crawling under a pile of offcuts to plug in a sander.
What about the ceiling? I see people with those retractable reels hanging down like they're in an ER.
Retractable cords are a godsend for the middle of the room, as long as you don't buy the cheap ones that lose their tension after a week. There is nothing more aggravating than a cord that hangs at forehead level while you're trying to move a sheet of plywood.
We saw some of those professional electrical drawings, the ones with the circles and the zigzags. They look like a secret language. Should a hobbyist actually learn to read those?
You don't need to be an engineer, but you should know the legend. A little circle with 2 lines is an outlet. A circle with an S is a switch. If you hand An electrician a drawing that actually shows where your power-hungry tools are, the ones that need their own dedicated circuit. You'll save a fortune in labor.
Dedicated circuit. Define that for the folks at home.
It means that wire goes from the breaker to one thing and nothing else. Your dust collector should be on its own. Your air compressor should be on its own. If they share a line, the moment the compressor kicks on while the vacuum is running, you're in the dark. It's like trying to share a single straw with a giant. Someone's going to end up thirsty.
Let's talk about lighting. My current shop has one lonely bulb in the center of the ceiling, which means every time I lean over a project, I'm working in my own shadow.
That's the hallmark of a builder-grade garage. It's fine for finding your car door, but it's a nightmare for joinery. You want layers of light. High-output LEDs are so cheap now there's no excuse. I like to run my lights on a completely separate circuit from my tools.
Why?
Because when you jam a piece of wood and the saw trips the breaker, you don't want the lights to go out too. There's nothing more terrifying than a spinning blade you can't see anymore. Trust me on that one.
That sounds like a tiger lesson if I ever heard one.
It was a very quiet, very scary 30 seconds in the dark. Now I keep the lights on their own breaker and I use task lighting. I have a light right over the sharpening station, one over the drill press and one over the assembly table. If you can't see the grain, you can't read the wood.
And what about safety? I know we have to talk about GFCIs.
Ground fault circuit interrupters. If you're in a garage or a basement, the code usually demands them. They're the little lifesavers. They monitor the electricity, and if they detect it going somewhere it shouldn't, like through you, they kill the power in milliseconds. They can be finicky with big old motors, but they're better than the alternative.
So, summarizing the Tiger Den blueprint. Audit your amps, pull a subpanel if you can, give the big tools their own dedicated straws to drink through, and for heaven's sake, keep the lights on a different circuit.
And don't be afraid to ask for more than you think you need. Wire is cheap. Tearing out drywall later to add one outlet you forgot is expensive. I always tell people, think about the tool you're going to buy for your 50th birthday and wire for that today.
What's your 50th birthday tool?
A 3-phase industrial planer that sounds like a jet engine. I've already got the outlet waiting for it.
Spoken like a man who has learned the hard way.
The path to a good shop is paved with blown fuses and tripped breakers. But once you have that steady, clean power, everything changes. Your tools sound better. They cut smoother. It's like the whole shop finally relaxes.
I think the takeaway here is that your electrical system shouldn't be an afterthought. It's the skeleton. Without it, the muscles, your tools, can't do the work.
Well said. Just remember, if it sparks and it's not a welder, you're doing something wrong. Thanks for hanging out in the den today. Now go check those motor plates and see what your shop is actually asking for.
Catch you next time.